Hello, my name is Craig Poskis. I am doing Chapter 15 on host defenses for Mr. Dorkowski, Bio 150. So there's going to be three natural defenses that your body has. I'm going to briefly discuss all three of them. The first line of defense is going to be physical barriers. Examples of this would be like skin, eyelashes, mucous membranes, nasal hair, eyelids, urination, stuff like that. Um, the second one's going to be a chemical barrier, which is like antimicrobial molecules and a low pH level. And then finally is a biological microbiome. So moving into physical barriers, on the first line of defense, you have the most important first line of defense, and it's going to be the one that I focus more into, um, is the skin. So imagine like a fortress. The wall is the first thing that protects from enemies getting inside of the fortress. The skin is much like this. Um, the skin is our outer wall protecting us from bacteria from entering. It is, once again, the most important first line of defense. The skin is broken down into two different parts: the epidermis and then the dermis. The epidermis is it's a thin outer layer, and then the dermis is a thicker inner layer of our skin. Alright, so let's move on to the most notable part of the skin. This is going to be the most outer layer of the skin. It's called the epidermis layer. Epidermis is closely packed cells known as the keratinocytes that produce keratin, which are insoluble protein that are resistant to bacterial enzymes and toxins. Outer skin cells also continuously shed and has a low pH that defers many microbes. Different parts of the body have different pH levels that do this, but what that does is that it's very acidic and it defers bacteria from trying to enter. So the innermost layer, the dermis layer, it's an inner thick layer of skin. It's made up of connective tissue. Um, the dermis contains the sebaceous glands that produce this oily substance known as sebum. Sebum is unsaturated fatty acids. Um, they inhibit growth of certain bacteria and fungi. The dermis also has sweat glands that flush microorganisms from the surface of the skin. Um, the perspiration that is produced from the sweat glands is it also contains antimicrobial peptides and lysosomes, which also prevents from foreign material entering. So moving on to the second example I have for the physical barrier. The first line of defense is going to be the mucous membrane. Mucosa is a membrane that lines different cavities in the body and surrounds the internal organs. The mucosa is constantly shedding and then is replaced by stem cells. The mucous membrane secretes a liquid known as mucus, obviously. The mucus lubricates cavity surfaces, but most importantly, they help trap different pathogens from entering the body. Example would be nose hair and cilia in the throat. Create mucus to trap different uh, pathogens such as like dirt from entering our bodies. Moving on to the second line of defense, it's going to be bacteria and phagocytes. So I want to focus more on the phagocytes. then the bacteria aspect of the second line of defense. So the phagocytes, we have two main ones, the macrophages and the neutrophils. Um, what they do is that they will target foreign enemies. Once the foreign enemies are inside of the body, the histamines will be released. This will trigger a process known as the inflammation response. And the inflammation response is a process of which phagocytes will destroy bacteria. So going to the process of inflammation response, you got three main steps here. So first one, it can be a little tedious at times, but it's fairly simple. But the first step is that it increases the diameter of the blood vessels. This will allow the phagocytes to pass through the vessels more easily, I should say, faster. Second step is the permeability of blood vessels increase, making it easier for the phagocytes to pass through into the tissues. That's the main thing. And that the step two is that it makes them able to pass through tissues. And then finally, step three, increasing the temperature of the body inhibits the foreign enemy from replicating and destroying by destroying the enzyme process. So the next step is going to be phagocytosis, which is pretty self-explanatory concerning that it deals with phagocytes. But this is the process that the phagocytes actually destroy the foreign enemy. Um, so how it starts out is once the phagocytes attacks the bacteria, it will begin to change shape and absorb or eat the bacteria. It just surrounds it and engulfs it. Once the bacteria is inside the phagocyte, it is surrounded by phagosomes and other chemicals such as lysosomes that is poured onto the bacteria that is engulfed. This will then destroy the bacteria, leaving um, residue behind. Um, Once the bacteria is destroyed, an antigen will be displaced on the MHC marker. Then the debris is released from the phagocyte. The remains will be filtered out using the lymphatic system, the lymph nodes, that process. And last but not least, the final third line of defense that our body has, it's going to be T cells and B cells. T cells as in Tango, B cells as in Bravo. Okay, so moving into the first example that I have for the third line of defense, it's going to be T cells, T as in Tango. Pretty straightforward. They migrate to the site of infection. They then release a cytotoxin, and then that will kill the invading pathogens directly. They don't um, inhibit it. They don't do any of that mess. They simply just release a cytotoxin that kills the pathogen. Okay, so moving on to B cells, the second example I have for the third line of defense. B cells have just a couple more steps than the T cells would. Obviously, it's got three steps. Um, the first one is going to be the B cells are activated when antigens enter the body, becoming plasma cells. This leads to step two, which is plasma cells produce antibodies. And then finally, step three, the antibodies bind to the antigens and then neutralize them and uh, uh, destroy them, basically. How they would neutralize them is that they would kind of do what I've previously stated in the phagocytosis. They would surround them and then make them unable to replicate. is slowly dying out. The the bacteria that has been